Welcome to Algebra 2, Lesson 2-3, Example 3. So in the last example, we looked at how zeros of the function and factors are related. And so we came up with this zero product property. We looked at this and we know that the factors, when you factor the quadratics out, you can solve for the expression equal to 0 to to find the zeros of the function, right? So we're going to use this property to solve quadratic equations by factoring. Example 3, solve the equation, part A. So we have a standard form here, x squared plus x equals 42. And this is not we don't know if this is where this is going to be used. It doesn't say it's a function, but we could, there's no other variable other than x, right? So like it doesn't have to be a function. But this is an expression, this is an equation, right? But we can make this a function and set it equal to 0, right? We can say it's a quadratic equation. And then we can set it equal to 0 to use a zero product property. And if we set it equal to 0, that means we're still not going to, we still don't want to change our equation. So we're going to use the property of equations to subtract 42 on both sides, right? And then that moves our 42 on the other side, and then that equals to 0. So then we can factor our quadratic equation out, and it happens that it's a pretty number, x plus 7 and x minus 6, to be factors of negative 42. That adds up to positive 1, right? So then, using zero product property, x plus 7 could be 0, x minus 6 could be 0 in order to be multiplied to 0, or they could be both 0. So we want to figure out when x plus 7 is 0 or when x minus 6 is 0. So x could be negative 7 or positive 6. These are our zeros. So using factors, we can easily figure out zeros. So this is the algebra way. Let's look at part B in example 3. So example 3 continued. Part B, 2x square equals negative 9x plus 5. In this case, we have a coefficient in our first term, in our quadratic term. That means we have to have 2x times x. Because it's positive, our factors are going to be both positive or both negative. You're gonna find a positive factor so that it's the same. If you find both negative factors, your m and n, your other factors, your zeros are going to be still the same, but when you solve for zeros, it's going to be the same. So use positive in this case, okay? And then you're going to find factors of negative 5. That adds up to positive 9. So 5 comma 1, so 5, positive 5 and positive 1, negative 5 and negative 1. You're going to add them up. It has to be positive 9, so it's probably going to be 5 and 1. But one of the factors have to be multiplied by 2 to be added, right? So factors of 5 times 2, one of them times 2 plus the other factor has to be 9. And so try 5 and you'll get 11, right? So maybe try 1 and then you'll get 2, right? But that doesn't really make plus 9. In this case, you want to solve by grouping. So factoring by grouping is another method when you don't have a pretty little number for m and n here. Okay, so in this case, we're going to rearrange a little bit. We're going to split. Factors of 5 will make multiplication. Product of factors of 5 will add up to 10. but not 9, right? So if you multiply one of the factors by 2, you'll have a different answer. So then you want to rearrange that. 2x squared minus x plus 10x minus 5. So first, we have to think about factors of 5. So the closest factor or multiples of 5 would be 10, right? So we can add x and then subtract x. Does that make sense? So 9x, in order to get 9x to 10x, we're going to add x. But then in order not to change the equation, we have to subtract x, right? So then 9x plus x would become 10x, and then we have a negative x here. So we're going to factor this out, and we're going to factor this out, right? It's going to be a group. So we're going to split it in half like that. And so the greatest common factor for the first group would be x. So factor that out, x times 2x minus 1, plus the greatest common factor for this one would be 5. So factor that out, you get 2x minus 1 as well. Oh, and now we have the same factor. And so you can factor x, 2x minus 1 out. And then we have x plus 5, and then times 2x minus 1. So it's distributive property again by using binomials. So now we can use the zero product property in order to solve for zeros. So x plus 5 could be equal to 0, or 2x minus 1 could equal to 0. Solve for x, and it'll be negative 5 or positive 1 over 2. So now we have solved the problem. Okay, so factoring is important. You need to know how to factor them. So try number 3, solve the equation by factoring. Sometimes they could factor out really nicely, like part A, but sometimes you have to factor by grouping. You have to be flexible. You may have to add some terms up and group them. All right, so pause the video and try number 3 and come back when you're ready for answers. Are you ready? Okay, so first of all, for part A, you would want to make them equal to 0 first, and then factor them out, right? So in part A, you have x plus 8x minus 20 equals 0. And then you want to factor this out. Factors of negative 20, that would add up to positive 8. Would we have a nice little factor like that? Yeah, so there are a lot of factors. 120, 210, and then 4 and 5. Those are the pairs of factors of 20, negative 20, right? But one of them has to be negative, one of them has to be positive. And so 20 and 1 would probably not make an addition a sum of 8, right? So we want to pick another pair, maybe 4 and 5, right? Either one has to be negative. If 4 is negative, you would have positive 1 if you add them up. If 5 is negative, you would have negative 1, so that's not correct either. 2 and 10, yeah, I think 2 and 10 would work, right? 10 minus 2 would be 8. So you would have positive 10. Okay, so you would have positive 10 and negative 2. And then if you solve for zeros, x plus 10 equals 0, and x minus 2 is equal to 0, right? Then x would be negative 10, or x could be positive 2. So yeah, x is negative 10 and positive 2 for part A. Part B, you would have to factor this out as well. You would probably use grouping. So let's first move everything to one side and isolate 0. Make the other one 0. And then you want to factor by grouping. Let's see, factors of 2 are limited, but you have to multiply by 2x, right? In order to do that, we can make the first group -2, right? Or maybe we can make it, what if we have 2x and then, let's see, +2 or -2, because it has to add up to, and then we have 2x times -2, that's -4, and then you want to add 1 in order to get a factor pair of, oh, it has to be -1 so that it's +2, right? So then it's going to add up to -3. There we go. So this one, we don't even need the grouping method. We're going to, yeah, we're just going to figure it out by the factors. And then now we can solve for zeros. 2x minus 1 is equal to 0. And x minus 2 is equal to 0. So 2x plus 1. 2x is equal to plus 1. And x is equal to +2. So x has to be 1/2, or it could be 2. Okay, so part A is -10 and 2. Part B is +1/2 or 2. All right, we'll continue with the next example, which is example 4, application problem. We'll continue in the next video.